Great. So for the second part, let me just quickly highlight something that, again, is not required for this course, but you may find really useful, and that's doing a correlation matrix. So you've done a correlation before where you can simply run the command COR, and you can do it between two variables in a data set, and you can look at those things. Let me just do that. And you can look at the correlation. But what if you want to check a bunch of correlations at once within a data set? And there are a lot of ways to potentially set this up, but what I want to show you is how to set it up for your homework too if you want to do it for that one. Now, here's the thing. Well, I'll just show you what happens when we try to use this command. So in general, when we do the correlation command, it expects two things, and then it correlates those two things, these two variables we put in here. Alternatively, you can simply just put in the name of the data set. What R does at that point is it says, I'm going to attempt to correlate every variable in this data set with every other variable. Since you did not specify any specific variables to pick, it will simply try to do all of them. And we set some specifications here. Use only complete observations. In other words, so it should use everything that's there. And then there are many types of correlations, but the one that we use in this class, the one you're used to seeing, is called the Pearson correlation. So this is just telling us to try to correlate everything in the NBA 15 data. Use complete observations, and I think that's just saying ignore missing data, and then use the Pearson method for executing the correlation. And that's the one, that's exactly what this is. This was a Pearson correlation, our nice linear interpretation for a correlation. So if I try to run that, though, we run into a problem. The problem is this. The correlation command only works when the only thing that R is reading in are numerical or integer variables. So it will not run if there are any factors or if there are any string variables. So with this NBA data set, I have a factor variable on conference. I have a factor variable on team. Because of that, COR doesn't work on running this whole data set at once. You'd have to get rid of the factor variables and any other character or string variables, and then do the COR command. And that's what I'll show you with this next example. So you can't use COR on your data set directly if you have any factors in it, because you can't actually compute a Pearson correlation with factors. That's a different point. That's not a part of this class, but that's the problem. They just need to be all numeric or integers. Now my Zillow data, my housing data, that should be all numeric. And yes, when I look at my Zillow data, my housing data, I have an integer, integer, numeric, integer, integer. Great. So let's try this again. So I'm going to say COR, try to correlate every variable in the Zillow data set with every other variable. Only use observations that exist, no missing data. and then use the usual Pearson correlation. And I will run that, and there it is. Beautiful. I have a correlation matrix. And it's just as a quick interpretation, if you're not as familiar with these, the correlation between any two things is simply where they intersect. So because each variable is correlated with every other variable in a correlation matrix, we always have ones down the diagonal because each variable is perfectly correlated with itself. So this is the correlation between bed and bed. This is the correlation between baths and baths, etc. And you can just interpret this directly. So if I look at this first row, the correlation between price and beds is 0.49. The correlation between price and baths is 0.77. So what you can do is you can use this to see which explanatory variables very efficiently have the highest correlations. And you can start with those explanatory variables as potential predictors to use in your model. Why would you use, just looking at this, why would I use bedroom? Why would I first test bedrooms over square feet? Bedrooms only has a correlation of 0.492. Square feet has a correlation with price of 0.88. So I know I'm probably going to want to start with this. Unless I'm doing backwards elimination where I include everything at once and then check what's significant or not. Point being, you can just use this information to your advantage. And as you might have noticed, what this is a matrix where the upper right of all this is simply a repeat of the lower left. Because I have price, for example, in a row here with everything else. Well, that's exactly the same as price in this column correlated with everything else. So we see that, yep, price correlated with bedrooms here is 0.491. And I can look across the other way and say, yep, price correlated with bedrooms here, 0.4915. So really you only need to look at basically one half of this correlation matrix because it's just repeating rows and columns in order to get this to show itself. So that's a correlation matrix. Not going to require you to run one. It just may be useful for you. Yeah, I talk about some other stuff here. If you want to, say, convert factors to numeric variables so that you can run your correlation matrix in a variable, on a data set that has factors in it. But all your data sets, you should probably be able to do this directly with your homework 2 data sets and use the correlation matrix to your advantage. Again, you don't have to use it, but you might find it useful. So that's it for this R script. And let me just quickly touch on it again. These last two things, this leverage and this Cook's distance, these are different ways to talk about how individual data points, I struggled over that word there, how individual data points influence our regression line, how they pull our regression line in different directions. And leverage just talks about one type of influence, and Cook's distance takes into account leverage and the residual value itself. So if you're interested in those topics, if you want to look at them more closely, please look through this and ask me questions. Otherwise, you don't need to worry about it. But just so you know that what the terms are, if someone talks about leverage, they're talking about influence from a particular value. Or Cook's distance is another way to incorporate all kinds of influence on our model, on our line, on our situation. So that's where these things come into play. But yeah, feel free to read the topics in the book about it and use it however you like, but I'm not going to be doing anything with it. Great. Well, I'm going to stop rambling here and send me questions if any of this didn't make sense. Thank you much. Have a great day.